Okay, greetings. Grade 12, we have calculus. The first questions. Okay, so these are our rules, and we haven't get into cubic as yet. Let's look at this problem. Number one, 8.1. What are we looking for? We are given f at x. Now let's determine the derivative from the first principle. Okay, you remember that the first principle is given by f at prime of x is equals to limit as h approaches 0 of f at x plus h minus f at x all over h. This is our formula for our first principle. Hence, we can just substitute here. We'll have limit as h approaches 0. F at x plus h means that where there is x, I substitute x plus h. So that means I'll have 3 minus into x plus h all squared minus, open bracket, you'll have 3 minus x squared. This is all over, we have h. Okay, that's the first thing. Number two, we go and say limit as h approaches 0. You'll have 3 minus x squared minus 2x h minus h squared. What did I do here? I had 2 brackets x plus h plus, into x plus h. Then this is x squared plus 2xh plus h squared. Then I multiplied by the negative to get this, okay? Now I have negative 3 plus x squared. This is all over h. Now I can see that this and this cancels out, and this cancels out. Then I'm left with what? I'm left with equals to limit as h approaches 0 of negative 2xh minus h squared. Okay, this is all over h. This is equals to limit as h approaches 0. I take out a common factor being h. I'm left with negative 2x minus h all over 0. Then this h and this h goes. Then I'm left with, as h approaches 0, I'm left with negative 2x, which is my final answer. Okay, so that's the first problem for 5 marks. Okay, the second one says now determine the gradient of the tangent of f where x is close to negative 1. Okay, so that is 8. This is 8.1.1, 8.1.2. I'll just take that one as it is. I will have f at x is equals to 3 minus x squared. Hence, f at prime of x is equals to, what do you call that? That will be 0 minus 2x. Okay, hence this is negative 2x. Then I substitute here my what? The negative 1. Negative 2 into negative 1. This is my gradient, right? This is my gradient. So this will be positive 2. That is the gradient they are looking for. Okay, so now we are done with that 2 marks. Now we go for with respect to x. So now I'm in 8.1.2.1, okay, 0.2.1, sorry, 8.2.1. So I have f at x is equals to negative 3x cubed minus 2 root x. Okay, this is, we'll have to simplify and get rid of the radical sign. This is negative 3x cubed minus 2x to the power of 1 over 2. Okay, then from there we can now derive When I derive, I'll say this is dy over dx is equals to, this will be negative 9x squared. This one will be negative x raised to negative 1 over 2. That is how we do it. Remember, when we derive, we use the law, the power rule that says a nx raised n, sorry, I wrote it wrong. It is n a to the power of x. Okay, this will be given by nx a to the power of x minus 1. This is our power rule. Okay, it doesn't matter which alphabet you use. Okay, that's how we did it. Okay, so 8.2.2, it now says f at x is equals to, oh okay, it doesn't say f at x. Let me correct myself on that one. It says xy. We have xy equals to, we have x minus 1 over x squared, x plus 1 over x squared. Okay, that is what we are having, right? Now you remember that if we have two brackets like this is a difference of two squares. Hence we'll have x squared minus 1 over x to the power of 4. This is xy, right? Then from them, this is equals to x squared minus x to the power of negative 4. Then this is xy. We divide everything by x, we divide by x, we divide by x. This and this goes. We have y is equals to x minus, this one will be x to the power of negative 5. Then from here I can now derive. When I derive here, I will say dy over dx is equals to, this one will give us 1 minus, this one will give us plus 5x to the power of negative 6. That is how we have derived. Guys, this is how we solve such problems. And you can count the marks. This is your calculus problem grade 12. Thank you.